How's it going, guys? Today in this video, what I want to do is I want to go over 7.3 and 7.4 and kind of go over the topics that we're going to be mostly quizzing you on and mostly testing you on in the testing quizzes that are going to be coming. Okay. So the first thing I want to start off with is actually these special factoring patterns. You should be able to name them, recognize them, use them when we're factoring actual polynomials, and you should also know their names. Okay. So for the first one, we have m squared minus n squared. This right here, it's called the difference of squares, and we call it that because we're literally finding the difference of two squares. Difference means subtraction. We're subtracting two square terms, so that's what we call it, the difference of two squares. Okay. The second one, we have m cubed plus n cubed. We call that the sum of cubes because we have two cubed terms and we're adding them together. So it's the sum of two cubes. The third one, we have m cubed minus n cubed. That's going to be the difference of two cubes, right? We have two cubed terms and we're subtracting them from each other. So we're literally finding the difference of two cubes. And that's what we call it, the difference of two cubes. Or the difference of cubes, you might hear it either way. M plus n squared and n minus n squared, both of these right here, they're both called perfect square trinomials. Okay? Perfect square trinomials. They're both called the same thing. They are slightly different because of the signs over here, but they both have the same name. You should be able to recognize them in doing problems. Okay, number 1 through 5, they're all going to be solved doing special factoring patterns. So I want you guys to kind of do it on your own, try to do them, and kind of get a good feel of what the special factoring patterns look like and how to use them. What I specifically want to go over, though, is number 5. Number 5, it's 4m squared plus 20m plus 25. A lot of times it's kind of hard to recognize if something is a perfect square trinomial or not. Two surefire ways that I like to check to see if it is a perfect square trinomial or not is the first and last term. It's much easier to check if those are both squares of another number than it is to check the middle term, right? The middle term takes a little bit of more work, but with a quick glance, we can see that 4m is the same as 2m squared, and 25 is the same as 5 squared. They're both squares of another number, so from there, I can check the middle term, and I won't feel like I wasted a lot of my time. I can see, well, 2m times 5 times 2, right? It's 2 times m plus n, so it's 2 times 2m times 5. That all equals 20m. So we know that number 5 is a perfect square trinomial. It's a perfect square trinomial. So we know that our answer is going to be 2m minus 5 all squared, right? We are using our perfect square trinomial right over here, and we can tell that it's going to be 2m. It's going to be 2m plus 5 from our perfect square trinomial. All right. And when it comes to perfect square trinomials, what I found useful is actually being able to go from the right side of this equation right here into your binomial. I find that it's much more useful to know that way than it is to know the opposite. You should know both ways. You should know all their names. You should be able to recognize them. But it's going to be especially useful for you guys to be able to go from the trinomial on the right to the factored binomial on the left. Okay? For number 1 through 4, I'll let you guys work that out, and I'll pause the video, and I'll have the answers in a bit. Okay? Okay? And here are the answers to number 1 through 4. We did number 5 together. Here's 1 through 4. Double check your work, see what you did, try to recognize what factoring patterns that I used if you got something differently, and see what you did wrong, you got something wrong, and if not, these are the right answers, okay? So let's keep on going. A good review that I'm going to be going over with you guys, that'll be good for the quiz. Not also be good for the test, but for 7.3 through 7.4, a good review here are going to be questions 18 through 30 in our review packet, pages 27 through 28. All right, so we're going to go ahead and factor a few of these. We did most of our factoring patterns in the previous slide, so we're just going to do a few of these, okay? The first one I want to do is number 19. Number 19, we have x cubed plus 5x squared plus 3x plus 15. Anytime we see four terms like this and we're told to factor, chances are you're going to need to do factor by grouping, okay? So let's go ahead and try it out, see if it works. We have x cubed plus 5x squared. That's going to be one group, and we're going to group up the last two terms, 3x plus 15. We're going to find the GCF of both pairs. The GCF of the first pair is going to be x squared, and we're left with x plus 5 inside. And for the second pair, the GCF is 3, and we're left with x plus 5 as well. We have another GCF right there. We'll take that out. And when we do, we're left with the coefficients. And that's our factored form. We can't factor out any more than here or any more from here. So this is where we stop. Next is do number 20. Number 20, what we can do, or rather the first thing we should always look for whenever we're trying to factor something is always look for a GCF. And for number 20, we have a GCF here, so we're going to factor out a 3. And when we do, we're left with m to the 4th minus 16. And when it comes to using your factoring patterns, I should have said this in the previous slide, but you should be able to recognize these factoring patterns even if you don't specifically say m squared or x squared or whatever exponent it usually is n. Because m to the 4th minus 16, that's the same thing as m squared all squared minus 4 squared. It's the exact same thing, and we should be able to recognize that. We're not going to do number 23, so I'm going to cross this out and keep working down. Okay? And from here, what we can see is that our a is m squared, or rather our m is m squared, and our n is 4. So we can rewrite this as 3 times m squared minus 4 and m squared plus 4, right? This right here inside the parentheses is a difference of squares when our term is m squared. Okay, m squared is the term being squared, so that is what we're going to do here. So we get 3 times m squared minus 4 and times m squared plus 4. And we can see that m squared minus 4 is another difference of squares. So we can factor that out one more time. And that factors out into m minus 2 and m plus 2. M squared plus 4 cannot be factored out anymore. So we just bring it down. And we stop here. And that's going to be our answer for number 20. For 18, 21, and 22, they're all pretty straightforward special factoring patterns that we saw in the previous slide. So look at them, try to do it yourselves, and try to compare it to our factoring patterns in the previous slide and see if you can factor it out yourself. Okay? Let's keep going. 24, we're asked to find the remainder with 2x cubed plus 3x squared minus x plus 1 is divided by x plus 3. We can use either long or synthetic division. Synthetic division, whenever you can do it, will almost always be easier than long division, and it'll also be much quicker. So when I have the option, I'm personally going to go with synthetic division. If you prefer long division, you can do it. I just prefer synthetic, and that's what I'm going to do. All right, so we're dividing by x plus 3. So if we're using synthetic, our a term is negative 3. So it goes in the top left corner, and since we're dividing all of this, we're going to use that as our coefficients. So we have 2, 3, negative 1, and 1. So we bring down the 2. 2 times negative 3 is negative 6. 3 plus negative 6 is negative 3. Negative 3 times negative 3 is a positive 9. We add down, that's an 8. Then a negative 24. And we get negative 23, right? If I went a little too fast, you're not comfortable with synthetic division, there's another video. You can go watch that, see how to do synthetic division, or you can go look at the completed notes or look up a YouTube video, whatever you like. But you should know how to do synthetic division if you're watching this video. And this is how you do it. and we get a remainder of negative 23. So our answer here is negative 23. Okay. Number 25 is x plus 2 a factor of 2x cubed minus x plus 14. We can use either long or synthetic division. Again, I'm going to use synthetic division. It's much easier. And remember, we're asking, is a certain term a factor of another polynomial? What that means is x plus 2, when you divide 2x cubed minus x plus 14 by x plus 2, do you get a remainder of 0? Does it multiply into it evenly? So in other words, if we're doing our synthetic division, here our a is negative 2. We should get a remainder of 0 if this is a factor of it or not. So we have negative 2. Our factors here will be 2. We don't have an x squared term. So we're going to put 0, negative 1, and 14. We're going to do our synthetic division. Drop down to 2. 2 times negative 2 is negative 4. Add down, that's negative 4. Negative 2 times negative 4 is a positive 8. Add down, we get 7. Negative 2 times 7 is negative 14. And we do indeed get a remainder of 0. So if we get a remainder of 0, that means, yes, it is a factor. And if we were to completely factor it out, what we'll do is we'll take that x plus 2 and we'll multiply it by our quotient that we just got down here, the 2, negative 4, and 7, which give us 2x squared minus 4x plus 7. Okay? And every time we do our, first this is actually called our factor theorem. Remember, if you're dividing a polynomial by a binomial and you get a remainder of 0, that means that binomial is a factor of the trinomial or the polynomial, whatever it is. Okay, so that's our factor theorem. And once we do our factor theorem, we always need to check if the quotient that we put in can be factored out even more. And here we have 2x squared minus 4x plus 7. We don't have any factoring, special factoring patterns that follow this route or follow this that form. So what I'm going to do is I'm going to check with the AC method. So I'm going to multiply 7 with 2, we get 14. And I need factors of 14 that add up to negative 4. I don't have any factors of 14 that add up to negative 4. So that tells me that 2x squared minus 4x plus 7 is completely factored out. So I don't need to go any further than this. Okay? So let's go on to 26. 26 tells us to use synthetic division to find p of 4 given p of x equals 2x cubed plus 3x squared plus 1. So that's our remainder theorem. If you don't remember what the remainder theorem is, it tells us whenever we need to find a value of a polynomial at a certain number, we can just use synthetic division with our a being that number to figure out what it is. So instead of plugging 4 into 2x cubed plus 3x squared plus 1, we can just set 4 as our a value and divide it using that polynomial. So our terms are 2, 3, 0, and 1. And we can do synthetic division to find it very quickly. Drop down to 2, we get 8, that's 11. We get 44. We get 44 again. Then we get 4 times 44 is going to give us a 176. And we get 177 as our remainder. And that remainder is what our answer should be. Let's go ahead and double check ourselves though. We're going to plug 4 into our polynomial. So p of 4, here we go, p of 4 should equal 2 times 4 cubed plus 3 times 4 squared plus 1. So when we do that, 4 cubed, we get 16 times 4. Let's do this really quickly, 24, get 64. 64 times 2 is 128. 4 squared is 16. 16 times 3 is 48. Plus 1. 128 plus 1 plus, 48. 16, 7, 176. Add 1, that's 177. Which is exactly what we got over here. So we are correct. We used synthetic division, and it was correct. Okay? That's just a good way to double check yourself with the remainder theorem. Okay? You can also plug it back into the polynomial if you're with the synthetic division. You should get the same thing. If you don't, you did something wrong on either side. All right? So let's keep on going. 27, solve the long division, show your work. I'm only going to do one of them. So let's go ahead with 27. We're told to divide 5x cubed minus 6x squared plus 5 with x plus 1. So with long division, we take our divisor, and we're going to divide it by everything above it, okay? So we could put, you put 5x cubed minus 6x squared. We don't have an x term, so we're going to put in a plus 0x plus 5. So along division, we're going to check how many times our first term in the divisor goes into our first term in the latest polynomial we have underneath the little division sign, x. So in other words, x times what gives us 5x cubed? That's going to be 5x squared. So we multiply the 5x squared by everything in the divisor. So 5x squared times x is 5x cubed, and 5x squared times 1 is a positive 5x squared. And I personally just like to put in the placeholders underneath the other terms, just so I don't forget to bring it down. And we're going to minus the first polynomial with the second one. 5x cubed minus 5x cubed is 0. Negative 6x squared minus 5x squared is a negative 11x squared, right? We have negative 6, and we're taking away another 5. That's negative 11x squared. Then 0x plus 0x, 0x minus 0x is 0x, and 5 minus 0 is just 5. Now we're going to keep doing the same thing. We're going to see how many times x over here goes into the first term in our latest polynomial. In this case, it's negative 11x squared. X times negative 11x gives us negative 11x squared. So we're going to multiply x plus 1 with negative 11x. We get negative 11x squared minus 11x. And I'm going to put a 0 right there as a little placeholder to remind me to drop down to 5. We're going to minus both polynomials. Negative 11x squared minus negative 11x squared is going to be 0. 0 minus negative 11x is the same thing as 0 plus positive 11x, which is 11x. Then 5 minus 0 is just a positive 5. Now, one last time, we're going to see how many times x goes in our latest term, in our first term in the latest polynomial, or in other words, x times what gives us 11x. That's just 11. 11 times x is 11x. 11 times 1 is 11. We're going to minus the first polynomial from the second one. 11x minus 11x is 0. 5 minus 11 is negative 6. So we just get negative 6, and we can't divide x into negative 6, so we just stop here. And this negative 6 right here is our remainder. And remember, we put our remainder over the divisor, or x plus 1 in this case. So if we're going to rewrite our answer, we get 5x squared minus 11x plus 11 plus negative 6 all over x plus 1. And that right there is our quotient for number 27. All right, and that's how you do long division. As a quick reminder. All right, now we're going to solve using synthetic division. We're going to do the same problem, and we're going to see, do we get the same answer as we did in the previous slide. Since we're dividing the same polynomial with the same divisor, we should get the same exact quotient. So we see here we're dividing by x plus 1. That tells me that my a is negative 1. So I'm going to put negative 1 in the top left corner. I'm going to write out my quotients, my coefficients. 5, negative 6, 0, and 5. Right? I don't have an x term, so I'm going to put a 0 there instead. And I'm going to do synthetic substitution or synthetic division, whatever you want to call it. We drop down to 5. 5 times negative 1 is negative 5. We add down. Negative 6 plus negative 5 is negative 11. Negative 11 times negative 1 is 11. 0 plus 11 is 11. Negative 1 times 11 is negative 11. And 5 plus negative 11 is negative 6. That's our remainder. And if we were to rewrite it, we get 5x squared minus 11x plus 11 plus negative 6 all over our divisor of x plus 1. And if we compare it to the previous slide, we got the exact same thing. So we got the same thing. Our answers are both correct. and we are good to go. All right. So that's pretty much everything from the review that we talked about. I guess one quick thing I want to touch on again on this slide right here is that you guys should also be able to recognize the special factoring patterns, even if we don't explicitly say x squared minus 16, for instance, for the difference of squares. Or in other words, you should be able to recognize something like this. We give you x to the 4th minus 25. You should be able to recognize that that's the same thing as x squared, all squared minus 5 squared. And then from here, it's a difference of squares, which is x squared minus 5, x squared plus 5. So that's what I mean. You should be able to tell that x to the 4th minus 25 is still a difference of squares, since x to the 4th is the same thing as x squared to the 2nd power. Okay? So you should be able to do that. Same thing with cubes. If we gave you something like x cubed minus, say, 27, you should be able to tell that's the same thing as x squared all to the 3rd minus 3 squared. Okay? You should be able to tell that those are the same thing. X to the 6th is the same thing as x squared to the 3rd. And you should be able to tell that this is going to be a difference of cubes. All right? So that's really all I have to talk about for 7.3 and 7.4, guys. Hopefully this helped. And have a nice day.